Hey guys, Mr. Catlin here. I'm looking at the wrong piece of paper. That's the one I want to look at. Okay. Practice problems 2.8 through 2.11. We're going to start with lesson 8, what we did on Monday. So we're going to look at these 3 problems in this video. Problem number 1, the relationship between a distance in yards, y, and the same distance in miles, m, is described by the equation that we see here. All right. A lot of you struggled with this on the quiz last week. Let me talk about this for a second. Hopefully some of you are actually listening to this and not just copying down the answers. We have a number that can be multiplied by m to get y. So if this is miles and this is yards, then we know the number that carries us over. That equation gives us so much information about what's happening here. We just got to use it. We got to know how to use it and how to use it to fill out this table. That's something that some of you need to practice for sure. So really, you're just multiplying the numbers on the left times 1,760. So that one's going to be mental, right? The next one, let me pull up a calculator for that. Let me go here and pull up my decimals calculator. Click beside my face there. All right, so the next one I got to do 5 times that 1,700 number. That 1,700 number was 1,760. So let me go back here. Calculator's pulling up. I want to do 1,760 multiplied by 5. So 1,760, and then we're multiplying by 5, 8,800. So this comes out to be 8,800. Now, if multiplying by 1,760 gives me that way, then I should know that bringing me back is multiplying by its reciprocal, or even easier, dividing by that same number to bring me back to these other numbers. Now, I'm expecting this one to be between 1 and 5 since it's between these two numbers. And I'm expecting this one to be greater than 5 because it's smaller than that one. Hey, Miss Mary Lou, I'm making a video, so just ignore me as I talk. So these two need to be divided by 1,760 to come over. So go back to my calculator, 3520. 3520, and I'm going to divide that. 3520. And then I'm going to divide that by our constant, which was 1,760. And you can see that that's equivalent to 2. So we're going to put 2 in our table right here. And then this number, the 17,600, that one needs to get divided as well. So I'm just going to click there and replace it with 17,600. Now, that one should have been pretty obvious. I don't know why I typed that in. It's just an extra 0, so 10 is my divisor. So 10 is what's going to go on the table right here. And that fills out our first part for part A. Now, this continues on to part B, and it wants to know, is this a proportional relationship between measurement in yards and measurement in miles per distance? And we know that it is because it had an equation that had a constant of proportionality. So we're going to say, yes, there was a constant of proportionality. That's how we know that it is a proportional relationship. We also learned that the equations, as long as they don't have exponents, addition, subtraction, or denominators with letters, then it's going to be a proportional relationship. So you could even talk about that. Yes, there was a constant of proportionality to get from one side to the other. And that's really what number 2 is asking. All you got to do is decide whether this is proportional or not. Does this equation over here represent a proportional relationship? So I'm not even going to look at what they're talking about. I'm going to come over here and look at the equation. Okay? Now, this matches what the equation says, which is great, but if it's got subtraction in it, I'm going to say no because subtraction, right? We can't have subtraction in an equation and it be proportional. We talked about that on Monday and Tuesday. All right, this one right here, they're multiplying 1.08 times P to get T. Now, that's okay. I don't have any addition, subtraction, no exponents, nothing like that. So I'm going to say yes to this one. That one's in good shape. I look over here. Now, this one is a dicey one. It's got a division bar. It's possible it's not proportional if there's a letter in the bottom. but we have a 4 on the bottom, so this one's okay. This is a proportional one, yes. And then the very last one that we're going to check, D, the equation for that one has a nice little bitty 2 up here in the exponent. That's a no-no for proportional relationships. No exponents are allowed in our proportional relationship equations. All right, let's look at a couple of other equations here on number 3. Number 3 jumps into talking about equations and filling out tables and determining whether it's proportional between x and y or not. Okay, so the first thing you could do is look at the equation. There's no exponents, there's no fractions with the letters on the bottom, and there's no addition or subtraction. So I'm going to go ahead and say that yes, this is proportional, okay? And the reason why this is proportional is because 5 over 2 is the constant of proportionality. Yes, 5 over 2 is the constant of proportionality. I'm going to abbreviate proportionality. And the equation tells me to take x and multiply by 5 over 2. So that means this table can be filled out by doing that simple math. Multiply by 5 over 2. Now, if you didn't know, 5 over 2 is another way to write 2.5. Half of 5 is 2.5. So literally, you can just multiply all 3 of these numbers by 2.5, and it will jump over to the side. Okay, so let's go do that. 2, 3, and 6 times that constant. So 2 times 2.5, 3 times 2.5, and 6 times 2.5. Those 3 numbers multiplied by 2.5. 5, 7.5, and 15. So let's go back here. 5, 7.5, and 15. And those are our answers for that table. Let's go and look at the other set, which has an equation right here that has a plus sign in it. I'm going to go ahead and say no. There is a plus sign. Plus sign in equation. That's how I know this is not proportional. There's a plus sign in the equation. That's a big no-no. But doesn't mean we can't fill out the table. The table says multiply your x times 3.2 and then add 5. So we got 2 steps here. We got to multiply by 3.2 and then add 5. And let's start with the number 1. Okay, so I'm going to come back up. We're going to do 1, 2, and 4. 3.2 and then add 5. Okay, so let me erase here. We're going to take 3.2 and we're going to multiply it by our x, which in this case is a 1, and then we're going to add, we're going to add 5. Okay, so the first one is 8.2 when we put 1 in x's place. So 8.2 for this first one. The second one, we're going to put 2 in x's place. So I'm going to go back to my calculator, and where the 1 was, I'm going to put a 2 because now that varies to 2. 11.4 for that result. So this is 11.4. And then we're going to put a 4 in x's place. So let's go back. Oh, wrong one. Let's go back here, and let's put a 4 in x's place. We get 17.8. So those are our numbers that we get when we plug into the equation, 3.2 times x plus 5. And it's not proportional because of the plus sign. You could also say there is no constant. We are not constantly multiplying by a number to get over. We're constantly multiplying by 3.2 and then adding 5, but not proportionally doing that. And that is the end of the video to help you with Lesson 8 in Unit 2. I hope this was helpful. Have a great afternoon, evening, morning, whenever you're watching this.